has the age-old question of whether or not our species is unique in the cosmos finally been answered. We might be getting closer to a game-changing finding thanks to the James Webb Space Telescope. Introducing K2-18b, a faraway exoplanet that has recently become a focal point in the field of astrobiology. Why? Its atmosphere contains an anomaly that the James Webb Telescope found, which may indicate the presence of life. The molecules that make up water vapor, methane, and the extremely rare chemical dimethyl sulfide aren't completely at random. Perhaps these are the biosignatures that have been puzzling scientists for so long, hints that extraterrestrial life does, in fact, exist. Our new guardian of the galaxy, the James Webb Space Telescope, JWST, is armed with the most cutting-edge space equipment ever built. Its purpose is to peer into the unknown and maybe reframe our notion of existence. The enigmatic universe of K2-18b could be something you're prepared to explore. We depend on the telescopes of our technological wonders to sharpen our understanding of the cosmos as we travel farther into space in quest of solutions to riddles that have baffled humanity for ages. Among these, the James Webb Space Telescope stands out. We owe a great debt of gratitude to the Hubble Space Telescope for decades of providing us with breathtaking and informative photographs of the cosmos. Still, not even Hubble is without its limits. Enter the James Webb Space Telescope, a telescope whose mission is to expand our understanding of the universe through the power of light. The JWST's cooling screen technology is among its most remarkable characteristics. The size of a tennis court, this multi-layered technical wonder blocks the heat of the sun, earth, and moon, making it far from an ordinary sunshade. Just how crucial is this? As a result, the telescope may be cooled to extremely low temperatures, making it more sensitive to feeble infrared signals given off by faraway stars. Exoplanets like K2-18b can only be studied with the use of infrared observations. Space dust can block or scatter visible light, but infrared waves can pass right through it, allowing for much better and more detailed photos. Infrared observations made possible by JWST represent not just an accomplishment but a game-changer for our understanding of faraway planets. What new information might we expect to uncover as our attention moves to K2-18b? The 124 light-year distance rock resides in the constellation Leo, but it's more than that. The habitable zone around a star is known as the Goldilocks zone, characterized by temperatures that are just right for liquid water to exist. K2-18b follows the same orbit around its parent star, K2-18. However, how is it different from other exoplanets that occupy comparable orbits? Scientifically speaking, K2-18b is a Hyzen world, not your average rocky planet. The discovery of habitable worlds with an oceanic surface and an atmosphere rich in hydrogen marks a new chapter in the quest for alien life. These planets provide environments that could be comparable to those around Earth's hydrothermal vents, which are known to be home to a wide variety of ecosystems. New information regarding K2-18b's atmosphere has been uncovered by the James Webb Space Telescope's recent studies. The atmosphere of this faraway planet contains a variety of gases and elements that potentially support life, or at least life as we know it. These include water vapor, methane, and possibly even dimethyl sulfide. The scientific community is ecstatic about the finding of these atmospheric components. The scientific community is abuzz with anticipation and conjecture as they consider these findings and what they could mean for astrobiology and the search for extraterrestrial life. The peculiar atmospheric makeup of this Hyzen world raises the intriguing possibility that it holds the key to understanding life beyond Earth. What does the future of astrobiology hold in light of its unique conditions? One of the most difficult and potentially lucrative parts of exploring extraterrestrial planets is learning about their atmospheres. The unusual atmospheric composition and distinctive habitable zone placement of K2-18b make it a compelling case study of how exciting and fruitful these kinds of investigations may be. A completely different cocktail is presented by K2-18b compared to Earth's atmosphere, which consists of trace gases, nitrogen, and oxygen. The hydrogen-dominated atmosphere of this exoplanet is rich with scientific mysteries, as it contains trace amounts of water vapor, methane, and even dimethyl sulfide. Researching an alien planet's atmosphere from over 100 light-years distant is no picnic. Spectroscopy, a method that studies the transmission of light from a planet's parent star through its atmosphere, is used in this process. The makeup of the atmosphere can be deduced by analyzing the distinctive fingerprint created when various molecules absorb light at different wavelengths. James Webb Space Telescope's infrared capabilities were important in these findings. Many chemicals that were previously difficult to identify are now within reach, thanks to the mid-infrared instrument's expanded wavelength range. Scientists are wondering what kinds of life could live in K2-18b's atmosphere. Because of the abundance of methane and the absence of ammonia, since biological processes on Earth frequently result in methane, the discovery of this gas on K2-18b raises the intriguing prospect of hitherto unseen life forms adapted to a hydrogen-rich environment. Additionally, a subsurface ocean may be present based on the atmospheric composition of K2-18b. This gives rise to intriguing inquiries on the dynamics of the atmosphere-ocean interactions and their potential impact on the habitability of the planet as a whole. Are we going to learn anything new about habitability and extraterrestrial life from its atmosphere? Typical Earth-like settings come to mind when we consider the possibility of life. Nonetheless, we have found evidence of life on Earth in previously unimaginable locations. Exploring extremophiles, organisms that flourish in harsh conditions, can shed light on potential extraterrestrial life. Hydrothermal vents located deep within Earth's seas erupt hot water that is rich in minerals, forming an ecosystem that is both dark and brimming with life. There, thermophiles and acidophiles flourish, casting doubt on our long-held assumptions about the conditions necessary for life. Do you think exoplanets like K2-18b might be home to life like this? Unique circumstances for hitherto undiscovered life forms exist in K2-18b's hydrogen-rich atmosphere. Methanogens, a type of microorganism that thrives in oxygen-depleted settings and produces methane on Earth, might thrive in this atmosphere. If the methane in K2-18b's atmosphere is biologically created, from the corrosive Rio Tinto rivers in Spain to the Siberian tundras, the study of extremophiles broadens our knowledge of the circumstances that can support life. The fact that life may be found on Earth in such a broad range of harsh conditions makes us reevaluate the ecological boundaries of life beyond Earth. As a possible exoplanet with a hydrogen-rich atmosphere and an ocean beneath its surface, K2-18b is a prime candidate for extreme life investigation. Maybe this faraway planet is home to a different kind of extreme life, one that has evolved to thrive in its own peculiar environment. What could the evolutionary history of extremophiles on K2-18b be like? Complex life on Earth developed from simpler forms that lived as single cells. Is it possible that, under ideal circumstances, a comparable process may take place on other planets? Dimethyl sulfide, DMS, could be present in K2-18b's atmosphere, which is one of the most intriguing things about studying it. This chemical, which could be a biosignature, is regularly made by phytoplankton on Earth. Does its existence on K2-18b and other exoplanets suggest the possibility of life? After being oxidized in the atmosphere, DMS contributes to cloud formation in Earth's oceans. The discovery of life beyond Earth may hinge on its existence in an exoplanet atmosphere similar to K2-18b. We are still in the process of testing K2-18b for the possible detection of DMS. Although such complicated compounds can be detected by the JWST's mid-infrared instrument, their presence must be confirmed by meticulous investigation and expert opinion. Scientists are ecstatic about the potential biosignatures found on K2-18b, like DMS. Nevertheless, it has also ignited a controversy, as is typical with any revolutionary finding. What DMS means for K2-18b is a contentious topic among scientists. Some see it as a promising biosignature candidate, while others point out that molecules with comparable structures can be generated by abiotic processes as well. The difficulty and complexity of deciphering extraterrestrial data is highlighted by this discussion. Skepticism has frequently greeted astronomical discoveries throughout history. At first, many people didn't believe Galileo when he said that Jupiter had satellites. There was also hesitancy when the first exoplanet was found in 1995. The importance of skepticism in the scientific process is highlighted by these historical examples. No one chemical or observation is crucial to the hunt for alien life. Researchers are on the lookout for biosignatures that, when combined, might provide strong proof of life. Is it possible that DMS, along with other biosignatures such as methane and water vapor, forms a bigger picture? Until further information is gathered, the discussion is likely to go on. The proof that DMS is a genuine biosignature may be forthcoming from future missions with even more sensitive instruments, provided that technology continues to progress. Does DMS hold the secret to finding extraterrestrial life, or is it just a diversion? Regardless of your stance, the ongoing discussion highlights how science is dynamic. Our knowledge of K2-18b and other exoplanets has been greatly enhanced by the James Webb Space Telescope. But this is only the beginning of space exploration, a long and winding road. How will technology develop in the future, and what lies beyond this massive endeavor to broaden our understanding of the universe? Another revolutionary project is the Extremely Large Telescope, ELT, which is expected to be finished by 2025. The world's largest near-infrared optical telescope, with a main mirror diameter of 128 feet, will be revealed. Biosignatures found by the James Webb Space Telescope may be confirmed or disproven by its unparalleled sensitivity. Findings from James Webb could be supplemented by data from another forthcoming mission, the Large UV Optical Infrared Surveyor, LUVOIR. With its versatile operating wavelengths, LUVOIR has the ability to acquire direct pictures of exoplanets and conduct more in-depth atmosphere assessments. Propulsion technology advancements are crucial as we aim for farther-away exoplanets. Ion propulsion and other possible approaches, incorporating antimatter propulsion, could allow probes to explore exoplanets within a human lifetime by substantially reducing travel times. We have an earlier video that discusses the potential and difficulties of interstellar travel. We should pause to think about the philosophical ramifications of our search for alien life as we are on the cusp of perhaps game-changing discoveries. How does this journey impact our comprehension of the universe, and what kinds of concerns does it raise about what lies ahead? A new mystery is the function of red dwarfs throughout the cosmos. These frequently ignored stars are the potential birthplaces of all life. They are intriguing hosts for planets that could support life because of their stability and durability. We would be confirming the presence of life beyond Earth and suggesting that the basic blocks of life are more universal than we formerly assumed. If we found extraterrestrial plankton or other kinds of life on planets like K2-18b, what mysteries will the coming decade unveil? Would we find more complicated mysteries that test our cosmic knowledge, or would we prove the presence of alien life? As we continue to push the boundaries of space exploration, the discovery of exoplanets like K2-18b opens up new avenues for understanding the vastness and diversity of potential habitats across the universe. The fact that we are now able to study exoplanet atmospheres in such detail marks a turning point in our search for extraterrestrial life. The combination of advanced instruments such as the James Webb Space Telescope, JWST, and future missions like LUVOIR and ELT will only enhance our ability to identify and analyze distant planets, possibly leading to the discovery of more planets with conditions suitable for life. These advancements in space exploration not only provide exciting prospects for the search for life, but also help refine our understanding of the conditions that allow life to thrive. Researchers are looking beyond Earth-like conditions, expanding the range of environments where life might exist. For instance, while we often associate habitability with planets that possess a breathable atmosphere and liquid water on their surface, planets like K2-18b challenge this conventional thinking by introducing the possibility that life could exist in extreme conditions that we might have previously considered inhospitable. Furthermore, the study of exoplanets like K2-18b encourages a broader view of what constitutes a life-supporting environment. While Earth-centric theories of life primarily focus on planets with a stable, temperate climate, the discovery of extremophiles on Earth, organisms that can survive in environments ranging from boiling hot springs to extreme acidity, has forced scientists to reconsider what is necessary for life to flourish. K2-18b, with its hydrogen-rich atmosphere, is the ideal candidate for further research into this expanding understanding of life's potential. These discoveries are also prompting scientists to examine the wider implications of their research, as they raise questions about the fundamental nature of life itself. The possibility of life on other planets could also have profound implications for humanity's view of its place in the cosmos. It might challenge our long-held assumption that Earth is the only cradle of life in the universe. While the discovery of extraterrestrial life would be revolutionary, it could also bring new ethical considerations, particularly regarding how we interact with and preserve alien ecosystems. The idea of encountering life beyond Earth also raises the question of how we might recognize and communicate with other life forms. Would extraterrestrial life be intelligent, or might it take forms far different from anything we can imagine? As we venture further into the unknown, it becomes clear that the search for life is not just about confirming the existence of alien organisms. It is about pushing the boundaries of knowledge, testing the limits of human curiosity, and exploring the very essence of what it means to be alive. The next decade of space exploration is poised to bring new revelations that will reshape our understanding of the universe. Each new discovery will bring us one step closer to answering the most profound questions humanity has ever asked. Are we alone in the universe? And if not, what does that mean for us? With the tools and technology now at our disposal, we are closer than ever to finding the answers.